This is Module 3. We're going to be covering some of the really early basics of C++ in terms of syntax, the literals, the way we store numbers, the way we store characters, and operators, some basic mathematical operators, and take a look at what's a little different in C++ and in programming from what you might be used to in terms of math operators from your other coursework. So when we talk about syntax, we're learning C++, and all programming languages, really all languages, even English, has rules, right? So sentences end with periods in the English language, in most languages. We've got a lot of symbols, and we've got grammatical rules that we need to follow. In natural languages, we tend to be very forgiving of syntax violations. So if we read something online or on a newspaper or something like that, if there's a spelling mistake, if there's a missing period, a missing comma somewhere, if the wrong word is used within a sentence, because we as humans, we're very, very good at sort of piecing together missing information or incorrect information, we can generally figure out what is being told to us, what we're reading, what we're hearing. The computer, or the compiler, probably more accurately, is very different. The compiler, if there's any syntax violations in our program, the compiler will become completely confused. It will not be able to continue. So syntax, the actual rules of the language, are really the first thing we've got to learn right away. And what takes a lot of getting used to is the realization that the details really matter. One missing semicolon, one incorrect character typed can prevent you from running your program at all. Now that sounds very kind of demanding, very scary. However, thankfully there aren't that many syntax rules. There's not that many things that we need to remember when we're developing C++. Over the next few modules, certainly we will learn what feels like a lot. But over time, you'll start to realize that the syntax really isn't that difficult. But today, or through this recording, you want to keep in mind that every detail matters. So in terms of syntax, we're going to see that. In terms of how programs are actually structured is another thing that we need to really pay close attention to. When we write an essay, when we read a book, we're used to seeing things in sentences and in paragraphs, maybe chapters. Programs are very similar to that, but we don't talk about paragraphs and chapters. Programs are made up of a series of statements, and we've seen this in the first few modules. Statements can be something like declaring a variable. Statements can be printing. Right? So we've had a lot of print statements that print out text to the screen. A statement is something that creates or forces the computer to take some action. Right? That's the easiest way of thinking about that. It typically contains an expression. We'll talk a lot about expressions later on in future modules, but expressions are something like 5 plus 6, something that can be evaluated, that has a value. Now these statements are grouped, just like sentences are grouped with paragraphs. We are going to group statements together, and there's actually a lot of different types of groupings in C++ and in any programming language. For now, I'll just kind of call them collections of statements, and I'll point them out as we go. But we'll learn their real names, and we'll learn exactly what they mean later on. All right, so the first collection of statements that we tend to look at the first time we see a program, in our first program that we wrote in previous modules, we had a simple cout statement. We had a set of cout statements, and you can see the cout, the printing statement to print out this is my first C++ course, and then an end of line. And we know that statements end in that semicolon, but what I want to bring your attention to is these brackets. Right? So these brackets, this is a function. Main is a function, and you can think of it as really just a primary grouping of statements. Statements can't just kind of float around in your source code. They have to be contained within something. And this something right now is main. This main function is bounded by these braces, these curly braces. Again, we will see loops, we'll see if statements, we'll see lots of other ways of using groups, but they'll always be bounded by these curly braces. They always have to be matched up. So an open brace always has to be followed by a closed brace at some point. We can have as many statements as we want within them. What I want to also point out is that the indentation matters here. So if you'll notice, after int main, and when we open up this curly brace, all the statements that are within this group of code are indented by one tab. And some people will use tabs, some people use a series of spaces. I tend to, in C++, use tabs. Visual Studio will automatically put those tabs in for you as long as your syntax is correct. And all of the code that is within these bounds, within these braces, should always be indented by 1 and line up on the left-hand column. Having your cout statements start maybe over at the same alignment as int over here, having them kind of misaligned, doesn't affect the compiler. The compiler actually doesn't care too much about space, whether there's a blank line here or not, whether there's a tab. But for a human reading your code, and that's really probably one of the most important things to remember when you're programming, you're always going to have to read your code. That formatting, those tabs, that proper alignment and indentation matters tremendously. So right off the bat, I want you to, we aren't in a race in terms of when we're writing programs. You shouldn't look to write your programs as fast as possible. What you should look to is paying attention to these details. So get into the habit right away for aligning your statements with one indentation within each one of these curly braces and have them line up together. Very important. Now if we look at these statements within the group in main, we've talked a little bit about this previously. We've got our cout statement. So cout is really just a command, and later on we'll actually call it an object in the semester, but for now we can think of it as really a command, and it's brought in and it's included through a library of C and C++ code called IOStream. So although the focus of this slide here is cout highlighted, what I really want to talk about here is the libraries. So C++ comes with, when you install Visual Studio, you're actually copying a tremendous amount of programming code onto your computer. And there's an actual file. If you look in Program Files under Visual Studio, there's an actual file called IOStream, which contains C++ code. A lot of C++ code, and it's not something that's easy to read at this point in your learning, but it is true C++. When you include, when you do this #include, the hashtag include, followed by an angle bracket and a library name, Visual Studio knows to go find that source code, and it'll actually compile the source code. It'll bring that source code into your program, and it'll become part of your program when you build it. So in this very, very simple program right here that prints out 2 statements, it's actually probably thousands of lines of code that are going to end up being compiled into your executable, most of which you're not going to write. It will be in the IOStream. And over time, we're going to start to include lots of other files. So we'll probably see maybe almost 10 different libraries that we'll include that will give us different commands. So IOStream gives us cout. Something like fstream will allow us to print to files, to read the files. Something like the math library will allow us to do square root and sine and cosine. After your include statement, and by the way, the include statements will always appear right at the top of your program. They'll be really the first thing that you write in your code. Perhaps you might end up with some comments ahead of it explaining what the purpose of the program is. But right away, you're going to do your includes. And after your includes, I'm going to recommend that you put using namespace std. This actually isn't 100% required, but in order to be able to use things like cout in a very clean and easy format, how we've done in this slide, we do need this statement. It's a bit of an oddball. It's actually sort of telling the compiler a little bit more about where to go find cout. It's specifically telling the compiler that when we are using something like cout, we're referring to the standard cout that's been declared in IOStream and not some other cout that might have been declared somewhere else. That's a little ahead of us. We'll talk a little bit about the value of namespaces later on in the semester. For now, just realize that every program that we create will have a using namespace std followed by a semicolon after any of the include statements. And again, we might have more than one include statement within our program. So you can see this semicolon over here, and you can see the semicolons over here. This using namespace std and these print statements are real actual statements. And again, one of the definitions that I use for statements is it causes the computer to take some action. And of course we know that the cout statements cause the computer to print something. Using namespace std also is telling the computer to do something. It's telling the compiler and it's telling the runtime system to go look in that standard library. Another important part of all of our programs beyond just statements is the keywords, the reserved words in C++. Keywords are really important because they're telling the compiler, they're telling the computer something very, very specific. And whenever we've got keywords in our program, Visual Studio is going to tend to highlight them in blue. That's not really what makes them special, but it's good to know. If you try to type one and you make a spelling mistake and it's not highlighted, you should try to check that and make sure that you correct it. Keywords, a lot of them we've already seen. We've seen using, we've seen namespace, we've seen include, we've seen int. I haven't really explained what int is yet, or return, and the rest of these data type ones we'll talk about in future modules. There's actually maybe 30 or so different keywords in C++. We'll use many of them. We probably won't use all of them throughout the semester. The important thing to know, we don't need to memorize all of these just yet, but the important part of this is that a keyword can't be used for anything but their intended purpose. So we won't be able to, once we start to create variables and we start to create other things within our program, we won't be able to use these terms for our own purposes. Just as a general rule, they are always in lowercase. Case matters, right? So everything in C++ is case sensitive. And that's very important to remember. C++ understands them, and again, we're gonna learn a few of them over the next few modules. So we've got keywords that form parts of statements. So if we look back over here, we can see we've got keywords. We've got keywords creating this namespace statement. We've got keywords that are starting this main function. Cout and ENDL would not be considered keywords at this point. Another part of these statements, though, is the string, right? The string that I'm actually printing out. This is my first C++ course. I hope it goes well. Those are literal values that end up on the screen. And I use the word literal because that's exactly what they're called in C++. So we've talked a little bit about binary. We've talked about binary numbers, and we know that memory holds just binary numbers. But somehow the computer needs to remember and know how to represent those binary numbers or to portray those binary numbers when it prints it out to the screen. So we've got data types, and we're going to talk more about data types in the next module or next few modules. But for now, realize that a computer or program can have strings, it could have integers, it can have floating point numbers, decimal numbers. Integers are restricted to not having a decimal sign in fractions. We can have individual characters, and note the difference between strings here. Strings, sets of characters all strung together and put together, have double quotes. A single quote for a single character represents a single character, but it cannot have more than one character within those quotes. So the literal representation for a string has double quotes. The literal representation of an integer is pretty straightforward. Same thing with floats, although realize we can also have other formats, scientific notation. The literal representation of a single character, and that distinction between strings is going to be important, is just with a single quote. And for Booleans, we've got literal values. Note that there is no actual quote here. For true and false for our values for Booleans. So throughout our programs, whenever we know a value that we're going to use in our program, we might write a literal in just the same way that you see on this slide. So why would we use numerics? Well, of course, we'd probably like to do some math, right? So one of the first uses of a computer program was to compute mathematical answers or mathematical problems. So we've got operators, and we'll see lots and lots of operators over time. But for now, we'll focus specifically on the math operators, the operators that you're probably fairly familiar with from obviously your past coursework. So if I've got a literal integer 3 and a literal integer 4, certainly I can write a plus sign, and we all know what that's going to do. And these expressions, and they're expressions in that they're going to be evaluated. 12 minus 3 is going to return back or be evaluated to 9. These expressions can be put in cout statements. They can be put in a lot of different places, in fact. So if we look over at this cout statement, we can see that between these arrows, instead of just printing out a simple string, now I've printed out 3 plus 4. And actually what we'll see to just come out to the screen is 7. Right? The 3 plus 4 will be evaluated. We'll get an answer of 7, and then cout will make sure that that answer appears on the screen. The star, the asterisk, is for multiplication. The slash and the direction matters, the /, is a division operation of two numbers. I want to point out some of the tricks or some of the little quirks with C++, or a few of that we'll continue to see a lot of them as the semester goes on. But some of these statements that we've got here are actually not going to give the answers or not going to give the results that we might be expecting. So what I'll focus on up here first is this cout statement. When we cout this, we would expect 9 and then whatever that answer actually is to appear on the screen and to make it be fairly readable. And of course, we would also expect this to end up being 2.5. We'll come back to what actually ends up being printed in a moment. But I just want to reinforce the fact that cout statement is actually using a different operator. So if we think about operators as plus signs, as division signs, subtraction, and addition, for printing there's also operators, and this double arrow that we've got down here is actually an operator. It's an insertion operator. Cout followed by an insertion operator followed by a value, an expression, the 7, the 12 minus 3, the 5 divided by 2. That insertion operator will ensure that whatever value comes to the right of these arrows ends up being printed to cout. It's kind of semantics. We're not really all it's not that interesting just yet why that's important, why we want to think about that as an operator, but it'll be a little bit more apparent as we go. So what I want to turn our attention to is actually running this program. I want to code this up in Visual Studio and run it and see what the output is. So I've already created a project here, and I'm going to just paste in that code. I'm going to correct my indentation. Remember, as I said, that's going to end up being a very important aspect of programming, keeping your code nicely formatted. I will build this. And we've got a success. We're going to go over to the command prompt. And just as a reminder, if you've been working on this in the lab, in any of the lab machines or at home, you want to get used to using this command prompt to run your programs. You want to make sure that you understand how to use the cd commands. You notice that I've cd'd into all the directories, the whole directory structure down to the debug folder to run my program. Once I've done that cd, I'm going to type in the name of my program and we'll have it run. Okay, so first thing that I want to point out here is, let's just look at the 3 divided by 4. The second line. The second line of our program printed out 3 plus 4. And notice that it did not print out the literal string 3 plus 4. It printed out 7. Right? So let's just focus right on that. So of course that's correct. Now if I go over here and I instead print out what looks to be nearly the same thing, but I surround it in double quotes, I'm going to get something very different. Right? So a string, now this is an actual literal value of a string, surrounded in double quotes, is going to be printed out just as is, as you've typed it. So if I rerun the program, I can see the actual values, or the actual characters 3 plus 4 being printed out. So that's an important point to remember. Right? Cout after the insertion operator will look at whatever comes to the right of it, and it'll evaluate it. And if it's a single literal, this is just a string literal, it'll just print it out. If it's an expression, actual numbers, or potentially characters as well, if it's actual numbers, it'll evaluate that expression and print it out. If I just had 3, that would be fine too. That's a literal integer value. And if I ran that, I would see 3 come out as the second line. Let's look at the first line. Actually, you know what? Let's look at the third line first. 5.3 times 8.9 actually ends up being 47.17. But you notice that when we look at the output down here, it doesn't really look like 47.17. It looks like 947. And the issue here is that 12 minus 3 evaluates to 9, and then this evaluates to 47.17. Cout only prints what you ask it to print out. Right? So it's literally just printing out the 9 followed by the 47.17. There's nothing else that Cout's going to print, and it's not going to think about whether or not that is going to confuse a user, and you're going to think that's 947. And remember, when you're actually working with a program, obviously it'll do something a little bit more interesting than this. The user of your program is not going to see your source code. Right? So when they see a number like this, there's absolutely no reason for them to believe that you printed out 2 distinct values. It looks like one value. So the simple answer to this, and it's a little awkward, but there's really only a few different ways of getting around it, is to print out a space between them. So in Cout, I can chain together. I can print as many things as I want. So first I'm going to print out 9, and then I'm going to print out the literal value of space, right? Just the space bar. Then I'm going to print out the answer to 5.3 times 8.9. That space will end up being in our output. And now when I print it, I can see 9 space 4717. Much easier, a much better result. And I could have used a comma, I could have used anything. Just remember that you only print out what is asked, what you've actually coded. And you have to keep that in mind. Right, so we kind of understand the second row. The third row sort of makes sense now, hopefully. I want to turn our attention to the first one, 5 divided by 2. And I want to point out that obviously it's not 2.5. It's coming out as 2. And the issue with this is that an integer operation, any integer operation where 2 integers are added together, when 2 integers are subtracted from each other, when 2 integers are multiplied, or when 2 integers are divided, the result always is an integer, which is kind of, we generally, when we think about doing math ourselves, and you're doing a math problem in a math class on paper, you don't really generally make the distinction between integers and floating point values, decimal values. If you write down 5 divided by 2, you just write the answer as 2.5, and you don't really think about the difference between integers and doubles, or floating point values. In C++, the data type itself is really, really important. It doesn't make any sense for the CPU to sort of, or from the CPU's perspective, the data type, whether something's an integer or whether something is a floating point value, depends or determines actually which circuitry is really even going to be in charge of doing the mathematical operation. It's going to determine how many bits and bytes are used to represent the answer. It's a very physical, hard constraint. So the data types really matter. So when a computer tries to divide an integer by an integer, it must, by definition, result in an integer. And it doesn't round it, it just creates a new integer, 2. All right? It takes that 2.5 away. It's called integer division. So integer division is something that it does take some some time to get used to understanding why that is. It can be a little frustrating, and actually it's one of these bugs that we will see in our programs even after you've been programming for years. You'll still occasionally forget about integer division, and you'll write some code and it'll have something like 3 divided by 2, and the answer to 3 divided by 2 from the computer's perspective is simply just 1. And it's easy to make that mistake, and we've got to consistently kind of keep our eyes out for that problem. So if I write down 3 divided by 2 in an expression in C++, the answer is going to be 1, not that 1.5. Right? There'll be no rounding, and the decimal place, you can think of it as being cut off, and in reality it never actually is even computed. There's separate hardware on the CPU to do integer division, and it does no real reference to the fractional values. Sort of on a similar note, we've got an operator called the modulus operator, that percent sign. The modulus operator allows us to get the remainder of an integer division. So it sort of goes hand in hand with integer division. So 5 modulus 2, or commonly called 5 mod 2, will result in 1, because 5 divided by 2 is 2 with a remainder of 1. 51 mod 8 is equal to 3, because 6 times 8 equals 48. Right? So 5 divided by 8 is going to be 6 with a remainder of 3. Right? So the modulus operator will give us that integer division. And that'll end up being pretty useful in several situations. So if we go back to Visual Studio for a second, you might be interested in, well, how do we fix this problem? Certainly computers can do mathematical operations with decimals. The key here is that if we're trying to do division, if we're trying to do any operation where we expect the result to be numeric values with decimal points, we need to make sure that at least one of the operands, at least one of the left-hand or right-hand side of this operator is a double, is a floating point value. And that's easy to do. We can just type this as 5.0, and that seems sort of silly, but from the computer's perspective, that 0.0 actually means quite a bit, because now this is a floating point literal, and it's telling the computer that this operation, this division operation, involves a floating point value, and we're going to have to use the actual circuitry dedicated to do floating point numeric computations. The result, even though this is still an integer, what C++ will do is it'll actually convert this to 2.0 for us. You're telling C++ that this is a high precision calculation. Any answer will come out as 2.5, and if we build it, we can see the result. Here we see 2.57, and then the rest. So in terms of observations, one of the critical things, learning how to use cout, we will learn a lot about how the syntax really works. We've seen that cout followed by the insertion operator. To the right of the insertion operator, whatever is to the right of it will be printed out to the screen. It'll be evaluated. So if you print out a string with double quotes, 5/2, close quote, you'll see that. If you print out 5 divided by 2, just as we've got here, that expression will be evaluated. It's a numerical expression, and it'll print out just 2. And the reason it prints out 2 is because it's an integer division. The result is an integer. If I print out 5.0, if I try to print out 5.0 divided by 2, I will indeed print out the 2.5. The key concept here is the issue of data types. Right? Whenever we multiply, whenever we add, whenever we divide integers, we use different circuitry in the CPU than we would if we were doing the same operation on floating point decimal values. So the computer is hardwired to give us an integer result in this case. The other thing to remember when we're dealing with outputting data out to the console is that we will only print out exactly what we tell cout to print out. So if we try to print out 2 answers right back to back like this, when we print out 12 minus 3 followed by another insertion operator and then 5.3 times 8.9, the 2 answers will appear side by side. Right? And we saw, we go over back to the console, we saw that 947.17 come out. The addition of a literal space as something extra that we print between the 9 and the 47.17 makes all the difference in the world to the output that comes to the screen. And we're going to actually learn quite a bit about output formatting. We can use a lot of different styles and different ways to format output to the console, and that'll be coming up. The last set of observations for this module is, we haven't learned all of the syntax rules just yet, and we'll certainly be integrating a lot more syntax as we go forward. But the main thing here is to remember that there's actually a lot of different types of errors that we can make in C++. So first off, some of the errors that we make are simply formatting errors. Lack of indentation, the lack of spaces between our statements. Formatting errors are not something that the compiler is going to complain about. It's not going to create a problem at runtime. But it makes a big difference when we actually go to look at our code. So again, just to remind you, if I wrote code something like, if I turned in code something looking like this, that's not going to change the output of my program. It's going to behave exactly the same. There's absolutely no difference. But from a neatness standpoint, from an organizational standpoint, it's wrong. We need to format our code correctly. Anytime we're inside one of these braces, everything within those braces should be indented by one tab and should line up. So I want you to think about that not as, well, it's optional. I want you to think about that as it's a formatting error. And if someone looks at your code, a colleague looks at your code, and if you're out and working doing programming, if a colleague looks at that work, it's sloppy and it's bad form. It's like turning in an essay with lots of spelling mistakes and no paragraphs or something like that. So it's important. Syntax errors are a little bit more loud, I guess. Missing a semicolon, mistyping a keyword. The compiler is going to complain about that. You're not going to be able to actually create a program. It's not going to output an executable. So syntax errors are certainly something that we need to worry about. Thankfully, when we do the compilation, Visual Studio will show us our syntax errors. So we generally can find them. Now, the syntax errors themselves, the messages that Visual Studio tells us, they might be a little cryptic. And as we go through the rest of the modules in this course, you'll see a lot of different error messages, and we'll learn how to interpret them. The last part about this, the last type of an error that we might see in our programs, and these are probably the most common, are runtime errors. They're errors that the compiler really has no idea about because the compiler doesn't know what you're trying to do. Only you know what your program really should try to do. So the program will run. The program will output the wrong information. And a very simple one was something like no space between printed numbers. If I look at my output over here, printing out 947.17, it's an error. It's wrong. From a user's perspective, that looks like one number, and presumably the purpose of my program was to print out two numbers, the 9 and the 47.18. The compiler doesn't know that. Leaving this out, there's no way for Visual Studio to know that that's not what you want to do. But nevertheless, it's an error. Right? It's wrong. And if you turned in a program like that and you printed out two answers side by side, it would be considered wrong. You would get points taken off in this case. So there's a lot of different errors. There's errors that can come up in terms of people looking at your source code. It's not formatted correctly. There's errors that can come up in terms of the compiler not being able to understand your code. And there's errors in that your program simply outputs the wrong things or perhaps does the wrong calculations. And we're going to need to consider all of these. They all matter. And part of the learning process initially for programming is getting used to these type of errors.